So this is my last video on this topic, and here I give you all the formulas that we have learned in this course. A set is a collection of objects. There are two ways of representing a set. The roster form, where we actually list down the elements, example all the elements 1, 2 up to 10, or the set builder form, where we write it in the form X. So X is the set of all elements such that X lies between 1 and 10. X is a natural number. Natural numbers consist of 1, 2, 3 and so on up to infinity. Whole numbers consist of 0, 1, 2, 3 and so on up to infinity. Integers is denoted by I or Z. It consists of the natural numbers 0 and negative natural numbers. Then I have rational numbers, which I denote by Q. It consists of numbers of the form P by Q, where Q is not equal to 0. Then I have irrational numbers, which are denoted by T. By irrational numbers, I mean numbers which are not rational. Example, root 2, root 3, cube root of 5. Then I have real numbers R, which consists of both rational and irrational numbers. Now, this is the union of two sets A and B. So by A union B, I mean the set of all elements which belong to A or B or both. This stands for the intersection of A and B, that is the set of all elements common to A and B. Then I have A minus B, which consists of the set of all elements X which belong to A but do not belong to B. So this is A minus B. Now complement of A I denote by A complement or A dash. It consists of the set of all elements X which does not belong to A. Now NA stands for the number of elements in A, and we have some basic formulae, that is number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of elements in A minus B is number of elements in A union B minus number of elements in B. Number of elements in B minus A is number of elements in A union B minus number of elements in A. And we have for three sets the same extension of the formula. Number of elements in A union B union C is number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection C. Again, we have De Morgan's laws, which states that A union B complement is A complement intersection B complement. A intersection B complement is A complement union B complement. Now, coming to relations, if A is any non-empty set, then any subset of A cross A is called a relation on A. And if R is a relation on a non-empty set A, R is said to be reflexive if A belongs to R for all A belonging to A. And we say A is related to A for all A belonging to A. R is said to be symmetric if AB belongs to R implies BA belongs to R for all AB belonging to A. We say A is related to B implies B is related to A for all AB belonging to A. R is transitive if AB belongs to R, BC belongs to R implies AC belongs to R for all ABC belonging to A. So we say A is related to B, B is related to C implies A is related to C for all ABC belonging to A. If R is a relation on a non-empty set A, R is an equivalence relation if R is reflexive, symmetric and transitive. And the set of all elements X such that X is related to A if R is an equivalence relation is called the equivalence class of A, denoted by this symbol. So this stands for the set of all elements which are related to A given that R is an equivalence relation. Coming to functions, if X and Y are two non-empty sets, f from x to y is called a function if for each x belonging to x there exists a unique y belonging to y. So I have a, b, c here. A is going to 1, that means we write f of a equal to 1, f of b equal to 2, f of c equal to 2. So 1 is the image of a under f, and a is the pre-image of 1 under f. So if f is a function from a to b, a is called the domain of f denoted by df. Now range of f consists of the set of all elements fx such that x belongs to a. So range of f is denoted by rf. So range of f is the values of fx and domain is the values of x. If f is a function from x to y, f is said to be one-to-one or injective if f of x1 equal to f of x2 implies x1 equal to x2. F is said to be surjective or onto if for every y belonging to y you can find an element x belonging to x such that fx equal to y. And f is said to be bijective if f is one-to-one and onto. If f is bijective, then f is invertible and f inverse exists. Now we have the vertical line test, which states that given a graph, if a vertical line intersects the graph at exactly one point, it represents a function. So this is a function because this vertical line intersects this graph at one point. Whereas here you have a circle which is not a function because a vertical line intersects the graph at 2 points. Then you have the horizontal line test, which states that if a horizontal line intersects the graph of a function at exactly one point, the function is one-to-one. So this is a one-to-one function because the horizontal line intersects the graph at one point. But again, this is not one-to-one because the horizontal line intersects the graph at 2 points. Now if f is a function from a to b, g is a function from b to c, g of f is called the composite of g and f, defined by g of f is a function from a to c defined by g of f x equal to g of fx. So domain of g of f is domain of f and codomain of g of f is codomain of g, which is c. Coming to binary operations, if A is a non-empty set, a binary operation star is a function from A cross A to A, such that star AB equal to A star B. So if A star B belongs to A for all AB belonging to A, then we say that star is a binary operation on A. So this is a test to use to check if it is a binary operation. You use A star B and check if it belongs to A for every AB belonging to A. Star is said to be commutative or abelian if A star B equal to B star A for all AB belonging to A. Star is associative if A star B bracket star C equal to A star bracket B star C for all ABC belonging to A. And if there exists an element E belonging to A, such that A star E equal to A equal to E star A for all A belonging to A, then E is called the identity element of A under star. A belonging to A is said to be invertible if you can find an element B belonging to A such that A star B equal to E equal to B star A. So B is called the inverse of A under star. Notice that inverse exists for each element, whereas identity is unique for the entire set under the binary operation. So we have covered all the formulae that you need to know in sets, relations and functions and binary operations. If you need to know more problems, you can check out my video. The entire video is available for a cost of just $7.99. Thank you.